But let's get into it. So firstly, let's change out these examples because these are what is going to try to be compiled by the compiler. So how are we going to change this? So we're going to get rid of all these. It's not a sum type. It's a schema. It doesn't take in any parameterized or index types. And then I guess what we need to supply is like nil or 0 or nat.0, which is just a nat, and then nat.suck, which I guess we'll write the same way. I guess so. Because I guess the fact that we're defining a schema means that these are primitives. So we don't need to have the fact that they're primitive anywhere. And that'll just be a nat to nat. So maybe we'll do something like this. No, we're not doing that yet. In fact, we may even just automatically convert those to those. I don't know. But yeah, I guess this is that. The naturals. This is going to stay the same. These disappear now. Well, we'll do that in a moment. Those disappear. And we're going to alias. Maybe it'll also be a schema, but it'll be parameterized by a type. A of type 0. It'll have no index types. And it's gonna have it's gonna have maybe dot nothing, which is gonna be a maybe A. And it'll have a maybe dot just. Which will be like that. Well, it does make it smaller. But it's still, I just really feel like these should be able to be decomposed out. It just, it pains me. Alright, so now we'll do vect. We'll keep the claim the same, but now the alias will be different. So what vect will be is it'll be a scheme, or schema, I guess. Like that. Oh, I guess. Yeah, do we really want to introduce a binding like that? I don't know how I want the syntax to look. And then a nat, and then here we'll have nil or vect dot nil, and this will just be a vect a0 or nat dot 0, like that, and then vect dot cons. Does this need to be indexed on nat as well? Is it implicitly bound? I don't know. So n is a nat. And then we want to take in an a, and we want to take in a vect an. And then we want to give back a vect a nat.suckn. And that should do that. Okay, and so if we want to get the head of a vector, yeah, so now we want to match on. I do want to be able to, So yeah, okay, let's match on a vect an, and we'll match on xs. And then this will be vect.nil. Maybe nothing a, yeah. And this will be a vect.cons. Maybe just a, well, yeah, sure. Sure. Am I going to allow variable shadowing? I don't know yet. Okay, and so if we want to write a predecessor function like this, I don't think we need to do that anymore though. So the type of map remains the same. Okay, we apparently did it this way. I kind of think that way makes more sense. Like that. And then we don't want to match on multiple things. We're gonna make this syntax better. It's fucking terrible. So let's get rid of that, because we don't need to match on the n. Because now we can just match on vec.nil. And we just return vec.nil. Yeah, see, I still don't know how I feel about this. What is the type of this branch? You can't tell. I think I might still force those to be there. It's kind of ugly. So then when padding matching, do we still match on the type? That's a good question. When we're destructuring, I feel like yes. I feel like anything else is just kind of weird. I mean, it's kind of weird to do in the first place since we get it from here, but whatever. And then cons, then we get rid of that. So I guess index types are ones that you don't need to include in every, I don't know. We'll redo this in a moment. So then here, I don't care. Here we don't need this anymore. Here I don't care, I do care. And then this should be like that, I think. No. Like that. Yeah, I think that's our map function. Let's redo this now. So proof that, well, I feel like we should allow like, if it's just one thing, no, because then how do you tell the difference between those things? I didn't know that's not 3 things. Damn it. Damn it. And then absurd we'll have to add at some point. Do we have to supply a proof something's absurd? I don't know how that would work. But, okay. Am I dumb? Also, why did I put that message in? It's not even true. Did you read the empty list? No, I assure you I fucking didn't. Schema must be used as a function. And we need to add schema to a list of things. It's a primitive operation. We're gonna keep primitive. I think the answer is no. I think that gets subsumed. No, I think the answer is yes. Maybe? Yeah, I think the answer is yes. We keep primitive, but it's not something you can parse. Like, it's not something you can type into the reader. That's not allowed. I think if you want to introduce primitives, it has to be done through, yeah, because otherwise we're back in the open edition case where anyone can add anything to any type, and I don't like that. I don't love that. So I think we'll get rid of primitives. That's not something you can enter manually, but it is something the compiler can generate, but it's not something that the user can input. Okay, we'll do that. So where is my cursor? Over here. Where is prim? Prim, yes. So we're gonna make that schema, and schema is gonna be a couple of things. It's gonna be, I should probably name them. I'll name them. I think I can do this. Schema, this will be, what do we call them? Params, t vector, and then we'll have indices, whatever. It's C's, right? Indices. I think that's right. Indices. Damn.